So, properties of rational exponents and radicals. These are all rules that you have learned before. You just learned them all with regards to regular exponents as opposed to fractional exponents. Now, I think fractions get a bad rap because they look different. Everyone wants to treat them different, but really they're no different than any other number. Okay? All right, so the first property we're going to talk about is called the product of powers property. And the product of powers property says, actually, you know what, before I start talking about that, let's talk about how you make up a power. That's what a power is. The whole thing together is called a power. All right? The big number that's at the bottom, does anyone know what that's called? The base. And the little number up top is called the exponent. So you're going to hear me use those terms a lot. Okay? So, if we have something that's written like this, you have two bases, and what do you notice about those two bases? They match, right? If you have two bases that match, what can you do with the exponents? You can add them. So, for example, with plain old numbers, if I had 5 to the second times 5 to the fourth, that would give me 5 to the sixth. Two bases that match, you can add the exponents. If I were to write this out the long way, this would be 5 times 5 times 5 times 5 times 5 times 5, and that's 6 total. That's how I get the 5 to the 6th. I really don't want to write out all those 5s if that's okay. Now, what we're going to say here is that that rule still applies even if you have fractional exponents. Now remember, fractional exponents can look like fractional exponents or they can look like radicals. And so if you've got radicals here, what do you notice about the radicals here? Even though it's all letters, do you notice that they have the same index and the same base? I personally think it's a little harder to see in radical form. I prefer to change it to exponent form because then I can clearly see that the bases match. So, if I have 5 to the 1/2 times 5 to the 1/2, that would be 5 to the 1/2 plus 1/2. Right? What is 1/2 plus 1/2? 1. So that would just equal 5 to the 2/2 or 5 to the first. So all that's a long way of saying even if your exponents are fractions, do the same thing to them. Okay? So. Here's another example if it was in radical form. If I had 5 to the first like this and something like this, wouldn't that give me the square root of 5 to the fourth? Right? Because I would add those exponents. Well, the square root of 5 to the fourth, again, I think it's just easier to go to exponent form. What would my exponent be if I changed the square root of 5 to the fourth to exponent form? What would the denominator be? Anybody? What's my index? There's no index listed, which means it's an index of 2. So that's my denominator. And the exponent is a 4. So 5 to the 4 over 2 would be 5 to the second, which is 25. And this one was 5. Okay? So a couple different ways that that particular property can look. Why is it called the product of powers? Because it's a power times another power. And multiplication is what gives us products. So? Do you remember that rule from before, using it with regular numbers? Hopefully. All right, power of a power. How is this rule different? Well, the main difference here is there's only one base. Here there were two matching bases. This time there's only one base. There's two exponents, but one base. So what is it saying? If you have one base or you have a power and it's being raised to another power, you multiply those two powers. I almost like to think about it like distributing that exponent in a sense. If you're distributing that exponent to something that already has an exponent, you multiply it. Okay? That's just going to exponent form. So let me give you an example here. If I had 3 to the 5/3 cubed. Now, let me show you the long way of thinking about this one. Ready? The long way of thinking about that is if this is what's being cubed, that means it's 3 to the 5/3 times 3 to the 5/3 times 3 to the 5/3, right? Isn't that what it means to be cubed? To be multiplied 3 times? Well, if I use the rule from up here, I've got some matching bases, right? So that would be 3 to the 5/3 plus 5/3 plus 5/3. Wasn't adding something 3 times to itself the same thing as multiplying by 3? So that's the shortcut way of doing this process right here. It's also easier if that outer number is a fraction. It's hard to visualize this going on. Okay? So let's multiply 5/3 times 3. Do you want to do it on your calculator or in your head? Most people aren't super comfortable with fractions, so they probably want to do it in their head or on the calculator. So again, let's get familiar with that calculator button that lets you do fractions. Okay, let me see if I have my... If you have a Casio, yours should be pretty self-explanatory because your fraction button looks like a fraction. Do you see that right there? Your fraction button? If you have a Casio. If you have a Texas Instruments or you borrow one of mine are Texas Instruments, there is still a fraction button. It's that one that says A, B over C. You see that? That's a mixed number right there. Do you see the whole number and then the fraction? That's a mixed number. Right above that, do you see the mixed number there? A, B over C goes to D over E. That changes something from a mixed number to an improper fraction. So if you get something that says 5 2/3, you press second and then this button and it'll get you to an improper fraction. Right above there, we're not going to use the PRB button necessarily, but we will perhaps at times look at what's above there. Do you see the F arrow D? Any guesses what that means? Fraction of decimal. If you are given a fraction, you can hit second in that button and it will turn it to a decimal, or vice versa. If you're given a decimal, it would change it to a fraction. Okay? These buttons are helpful to know. Okay? So, I'm going to take 5/3. How do I type in for 5/3? I press 5, fraction button, 3. Do you see that? I don't need to put parentheses around it or anything because as soon as I use that fraction button, it knows that those two numbers are a numerator and a denominator. If I use the division button instead of the fraction button, then I got to use parentheses. Okay? What am I multiplying that by? 3? My answer is 5. So this gives me 3 to the 5th power. By hand, why does that work? Well, 5/3 times 3, which is 3 over 1, is 15 over 3, which reduces to 5. That's what it is by hand. Now, whenever you have a number and a power, or a number and an exponent, I should say, I do actually want you to multiply it out. So what is 3 to the 5th power? Well, I use 3. Where's my exponent button? I call it the to the button because as I'm pressing it in, I press 3 to the 5th. So I call it the to the button. Get it? 3 to the, it's this little arrow pointing up. 3 to the 5th power is 243. So I would want you to write 243 as your answer. Not 343, 243. So whenever you have a number to a power, I want you to do that. Okay? Gesundheit. So? Okay. I'm going to show you an exponent form. a different example. Fourth root of 16. Now, I could use my calculator, and I could do the fourth root. Do you remember how to do a root that's not 2? This is your square root button. This is your root for anything other than a square root, other than a 2 index. Okay? So if I wanted to do a fourth root, I would press 4, second, and then my to the button to get above there. Now, if yours just says, a lot of people came up to me on Friday or Thursday or whatever saying, I plugged this in and I got something different. Well, the problem was they had 4 and then they had a square root. They didn't have that little X there. They pressed the wrong button. That's 4 times the square root of something as opposed to the fourth root of something. So be careful that you're using the one that allows you to use a different index as opposed to the square root, which forces you to an index of 2. So the fourth root of 16 is 2. Now, another way to think about that is if I have a fourth root, if I can think of this number as something to the fourth power, that can be helpful. I know that 16 is 2 to the fourth power, so do you see if I think of it as something to the fourth power, then I have a fourth root and a fourth power, and that's another way to get to that answer of 2. Okay? That might be helpful to think of when we're going through solving problems later. Okay? All right, next one. Power of a product. So there is a product or a multiplication problem that's being raised to a power. Well, when you have multiplication inside your parentheses, you can distribute that exponent and it applies to everything inside that parentheses. So here's an example. If I had 16 times 9 to the 1/2 power. Let's say I didn't want to do 16 times 9 because maybe I didn't have my calculator with me. Since this is multiplication inside, now that's the key, I'm going to say it again. Since this is multiplication inside, it doesn't work for addition, it doesn't work for subtraction, division we'll talk about in a minute, but it works for multiplication here. I can call this 16 to the 1/2 times 9 to the 1/2. And what did I say when we first learned this lesson? What does 1/2 as an exponent really mean? Square root, right? 1/2 power is a square root. So what's the square root of 16? Square root of 9. So by remembering that 1/2 as an exponent means a square root, I can eliminate my calculator need by using this property. Okay? Kind of makes sense? Okay, I'm going to leave that one alone now. Negative exponent, we talked about this one a lot the other day. Negative exponent does not mean anything becomes negative. What does it mean? It becomes a fraction. So if I have 25 to the negative 1/2 power, I cannot tell you how many times people say the answer to this is -5. And I can see where you might make that mistake, that -5 seems logical. We cannot make something negative just because it has a negative exponent. That means 1 over 25 to the positive 1/2 power. There's actually no negative in there. Right? And what is 25 to the 1/2 power? So my answer is 1 over 5. Yep. How did I get the 1 over 25 to the 1/2? Whenever you have a negative exponent, that means this is currently on the top of a fraction. That means that you move it to the bottom of the fraction and it becomes positive. If I had something that had a negative exponent and it was on the bottom, it would move to the top. You just put it on the other side of the fraction from wherever it is and it makes that exponent positive. Okay? Let's see. If you wanted, no, I'm not even going to go there. Okay, 0 exponent. anything to the 0 power equals 1. So if I had 5 to the 2/3 times 5 to the 1/3 times 5 to the -1. A lot of people will freak out there and go, oh, do I need to call the 5 1 or do I need to call this one 1/5? Well, you can. Or you can deal with all the exponents first and see if you still have a negative exponent afterwards. Because I want to refer back, actually, which property would this one fall under of the previous ones? I have 3 matching bases. It would go to the first one, wouldn't it? I'm going to add those exponents. So what is 2/3 plus 1/3 minus 1? 2/3 plus 1/3 is 3/3 or 1. Minus 1 is, so this ends up being 5 to the 0. I never, ever, 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 ever want to see a 0 exponent in your answer because anything to the 0 is just 1. Okay. All right. Quotient of powers. This one is very much kind of like the opposite of the product of powers. Product of powers, quotient of powers. Does it make sense that product would be the opposite of the quotient? When I have a product, meaning that they're multiplied, I'm going to add the exponents. When they're being divided, what am I going to do? Subtract them. Now, the important part here is when you are subtracting fractions, it is always top minus bottom. So the top exponent minus the bottom exponent. Okay? And do you notice that the answer is on the top of a fraction? Okay? That's just kind of important to recognize. So if I had something like this, 5 over 5 to the 1/3 power. Do you see the matching bases? What's the base? This would be 5 to the what power? First, if there's no exponent listed, it's an exponent of 1. So there's my matching bases. I would write this as 5 to the 1 minus 1/3. What is 1 minus 1/3? 2/3. And that's about as far as I can go there. Okay. So. All right. Now, remember how we did that power of a product one up here? And I said it works because there's multiplication in there. Doesn't work for addition, doesn't work for subtraction. Well, let me show you what happens with division. This is what it would look like. You'd have a fraction in parentheses with an exponent. If you have division, you can also distribute that exponent. It goes to both the top and the bottom. Now, a lot of times you will see this property in conjunction with the power of a product property, meaning that it won't just be A over B. You're going to have more than one thing on the top and more than one thing on the bottom. In which case, when you distribute, you have to distribute basically to everything in the parentheses. All the parts of the top and all the parts of the bottom. Everything's got to get it. Okay? So if I were to say, let's say I had x squared y over z. Well, let's say z to the 3rd. Okay? And I wanted to raise that all to the 4th power. Do you see the fraction in parentheses? That tells me that everything in this fraction, the x squared, the y, and the z cubed, all have to get that 4th exponent added to it. Now, when I distribute this 4 to something that already has an exponent, we have to multiply. So, that gives me what? X to the 2 times 4 would be 8. And then distributing it to the y gives me y to the 4th. And on the bottom, I have z to the what? 12th. And if there was more than one thing on the bottom, say there was a w also, you would have to distribute it to the w also. Okay? Let me show you in numbers here. 12 over 25 to the 1/2 power. What does 1/2 mean again? Square root. Is 12 a number you can take a square root of nicely? Is 25 a number you can take a square root of nicely? So we're going to get part of the way there. So this would become 12 to the 1/2 over 25 to the 1/2. And 25 to the 1/2 we know is 5, right? Because it's the square root of 25. Now, I don't like leaving this as it is because 12 is a number. I have to think about this as though it's that, right? And 12 is a number that I can draw a tree for. And I think there's enough on that tree that I can take something out. Yes? So I'm actually going to call this 2 radical 3 over 5. It makes more sense to put that in radical form because even though I can't take the square root of 12, I can draw a tree for 12 and take some stuff out. Yes?
Why didn't you cancel out the 1/2?
Why didn't I cancel out the 1/2? Good question. You're talking about right here?
Mm-hmm.
Because I can't cancel out exponents. I can only add them, multiply them, distribute them, move them to the other side. None of these rules, I can subtract them, I can distribute. I can't just cancel out exponents. I have to deal with them somehow using one of those rules. Good question. Okay. All right, so let's do some examples of like problems that you would see. So, by the way, these problems tend to be the hardest ones on the test. And I don't feel like they're that hard. I think that people just forget how to deal with them. Okay. So I look at this. Yes. Yes. And I look at something that's kind of confusing because I see x's, and that's good because those are bases that match. But I notice I have a square root and a cube root. And how do I combine a square root and a cube root? Kind of hard to tell. So what I'm going to do before I do anything else is I'm going to change this to exponent form to see if that helps me at all. So if I look at the numerator here and I wanted to write that as a fractional exponent, what would that be as a fractional exponent? 3 would be the numerator. What would the denominator be? 2. On the bottom, what would that fractional exponent be? 2 over 3. Now I have my bases kind of easy to see, don't I? What property am I going to use if I have a base over a base? Well, which one has fractions in it? That one has fractions. And that one, I think I've got that case going on, don't I? Because there's no parentheses to distribute anything. So what am I going to do? Subtract those exponents. So that gives me x to the top minus bottom. And I'm going to go to my calculator. Use that fraction button again. 3/2 minus 2/3 is 5/6. So my answer is x to the 5/6 power. Now, if my calculator, if I know how to use the fraction button on my calculator, do I need to be afraid of any of these problems that have fractions in them? No, I just got to type them into my calculator and let my calculator do the hard work. Kind of sort of get that? So? Okay. Let's look at the next one. Again, I have a bunch of different indexes. What are my indexes or my indices? 6, 4, and 3. Well, I can't really do a whole lot with radicals when they don't have matching indexes. That doesn't help me at all. So let's see if going to exponential form helps anything at all. This would be 16 to the what? 3 over 6. This would be 4 to the what? 6 over 4. and this would be 8 to the 2 over 3. I think 2 of those can be simplified. This is 16 to the 3/6 reduces to 1/2. This one reduces to 3 over 2. Okay. Haven't gotten a whole lot further except for the fact that I know that 16 to the 1/2 equals what? 4. Okay. Now, I think I can do something with this if I write it in the other radical form. Remember, this is the same thing as the square root of 4 cubed. Do you remember that? What is the square root of 4? 2. Cubed is 8. That's easier, isn't it? Can I do the same thing over here? That would be the cube root of 8 squared. What is the cube root of 8? 2. Squared is 4. So I really have 4 times 8 times 4, which is what? 4 times 8 times 4, 128. So sometimes you got to play around with, if it doesn't look clear for me to what to do in this radical form, maybe I need to change it to the other radical form, or maybe I need to change it to exponent form. One of those ways should show me what I'm supposed to do. I should get an idea. Okay? All right. What have we got going on here? Do I have matching indexes? Nope. So on the top, I have the square root of 64y. Okay. So that is 64y to the 1/2 power, correct? What do I have on the bottom? 64y to the 1/3 power. Now, some of you might be tempted to cancel out those 64s. Is that anybody's first thought? Say, hey, that's handy. Well, I can't because they're in parentheses. We got to deal with the exponents first. One thing I do notice is that these bases, 64y and 64y, though they're a little ugly, they match. So what can I do if I have two bases that match and they're written as a fraction? Subtract them, just like I did in this first example on the left. So that means I have 64y to the 1/2 minus 1/3. What is 1/2 minus 1/3? 1/6. Now, as a general rule, we don't like we don't like parentheses in our answer. So I'm going to use my little distribute rule there because this is multiplication. That gives me 64 to the 1/6 power, y to the 1/6 power. Now I don't think I can do anything with the y, but the 64 I might be able to do something with. Let's try 64 to the, watch this, you ready? Parentheses 1/6, using my fraction button. Let's see if that works. Whoa. See what I just did there? 64 to the 1/6 is 2. So I have 2y to the 1/6. So if I have a number, and I'm not sure if it can be simplified or not, plug it in with an exponent, or you can use your radical button, because you can go back and forth between radicals and exponents to see what can be done there. Okay? All right.